So this week I'm excited to introduce you to Ethers.js. Okay, so I've actually gotten some requests about this particular video, so I'm excited to show it to you today. Okay, because this is a really important library for you to understand if you want to become a blockchain developer. So I'm going to show you everything in this video, like I'll explain what Ethers.js even is if you're not even sure right now, and then walk you through how to set it up and get started using it today on your own projects. So what is Ethers.js? Well, it's a JavaScript library for interacting with the Ethereum blockchain. Okay, so you can use it to build dApps. You know, if you have a client-side application that talks to the blockchain, you can use Ethers.js. If you have a backend that's built in JavaScript that wants to talk to the blockchain, well, you can also use Ethers.js for this. So this is a very popular alternative to Web3.js. Okay, so if you've been to the blockchain bootcamp, or maybe you've followed any of the tutorials on my YouTube channel or inside this program as well, I typically use Web3.js. Okay, so there's lots of reasons for that. Web3 is the most popular library for interacting with the Ethereum blockchain, and that's one of the reasons I use it. But there are a lot of benefits to using Ethers.js, which I'll talk about in this video, okay? And at some point in your blockchain development career, you're probably going to run into Ethers.js, and that's another reason why I'm making this video, so you all can understand how it works and get up to speed fast by watching this video, okay? So let's talk about Ethers really quickly and just how it works from a high level. So, if you have a normal web app, let's just use that for example, and you want to build a dApp that talks to the blockchain, well, you need some special tooling to do that, right? So, most apps just talk directly to a centralized web server, okay? Okay, and there's no special tooling needed out of the box to make a dApp do this. So if your web app talks to a backend for a to-do list application, for example, and creates to-do items and it fetches to-do items, it can choose an API. It can basically make a web request to this web server with an API and just do it that way. Okay, there's no special setup required. But if your web application talks to a blockchain, all right, then there's no support out of the box from your web app to do this. Okay, so you need a special library to make this happen, and that's exactly what Ethers.js does. Okay, so if you're using my other tutorials where I use Web3, Web3 is doing this. Okay, so if you're using my other tutorials where I use Web3, Web3 is doing this. So basically, your web app, you install Ethers.js into it, and it turns your app into a blockchain app because it must talk to a blockchain. So really quickly, how to do that? Well, Ethers.js, it basically talks to an Ethereum node, all right? So, the blockchain is a peer-to-peer network of nodes all talk to one another, all right? And so, there's node, there's another node, and then there's another node, and another node, and then there's thousands of nodes. But that's all I do. The blockchain is this network of nodes that all talk to one another, and if you want to connect to it, then you need to connect to a single Ethereum node. Okay, and that's what Ethers.js does. It basically talks to an individual node in the blockchain, and you can fetch information from it, and you can write information to it with your wallet with Ethers.js. And I'll show you how to do that inside this video. So it's actually pretty nice because one thing you're going to see is that it's a lot easier to connect to the blockchain to an individual Ethereum node by default with Ethers.js than it is with Web3.js. So if you want to do some tutorials or something like that, then you can get started faster with Ethers.js. So you'll see that in action here in a minute. So why would you want to use Ethers.js besides Web3.js? Well, there are a few reasons, okay? And I'm just going to go to the GitHub repository here for Ethers.js and show you what they talk about and kind of call out some of those. So the Ethers project here, some of the main reasons are that you can get started really quickly, okay? So basically, you're going to see, like I said a second ago, that you can just connect to a default Ethereum node. You don't have to sign up for Infura in order to use it. It just gives you a default Ethereum node out of the box, okay? So let's go to what they say here on the page, though. Basically, it has a really small footprint, all right? So it's pretty small compared to Web3.js. Like if you ever install Web3.js and you see this giant terminal output, it can be kind of crazy. Ethers.js is pretty small. Another big benefit is that it supports these basically human readable APIs. I can find it, APIs. Human readable APIs. So you're gonna see that here in a minute. So if you're having to create smart contracts with Web3.js, sometimes you have to copy and paste this massive JSON blob and put it into your application. But with Web3.js, with Ethers.js, you can make these human readable versions, which is pretty nice. You'll see that in action here in a minute. The auto step that I talked about, where you can just instantly connect to an Ethereum node, is pretty amazing. And there's also it's kind of a simpler syntax, which we'll see in a minute. And finally, it supports ENS named out of the box, which is pretty cool too. So there are lots of great reasons, but you're gonna see some of those in this video. So go ahead and open up the code examples that I've supplied. There should be a link down in the video description below, and I'll show you how to use Ethers.js step by step. Okay, you'll see some of these examples in action. So go ahead and open up the app.js file, and let's clear some of this stuff out. Okay, we'll start with a blank slate here. I'll build this all out step by step. All right. So what we really want to do is just keep these two lines at the top. All right, and we'll build this file out as we go. So first and foremost, let's look at the package.json file, see what's inside here. So this has some dependencies in here, the .env dependency, which you'll see here in a minute, and then but the Ethers.js dependency. So Ethers recently upgraded to version 5, so that's what we're going to talk about in this video. I'll show you how to use the latest version of Ethers.js, and then you have a .env file, which we'll modify here in a minute as well. So you actually probably won't have this in your code example, or you might, but you'll need to add your own private key here in a minute. So I'm getting ahead of myself, so don't worry too much about that. But let's go and start building out the app so you can see how Ethers works. And so before we get started, let's install our dependencies. So go to your terminal here where you downloaded Ethers. You can just cd into that directory, say Ethers examples. All right, and then basically you can install the packages like this, say npm install. All right, so I've already done this, so it goes pretty fast, and that is a really nice part of Ethers, is it installs really fast as opposed to Web3, which I showed you a minute ago has a pretty big footprint compared to Ethers. Okay, so let's do something really simple. Like I said a minute ago, Ethers talks directly to the blockchain with these Ethereum nodes like this. So let's just talk directly to the blockchain, create a really basic test. Let's just try to get the current block number. So what do I mean by that? Well, this will be a smoke test. But what I mean by that is basically every time a new block gets mined on the blockchain, it has a specific number. Okay, it's kind of like an ID. So if you go to etherscan.io, you can see all the latest blocks. I'm going to look at this particular block, and we can see the number here. Okay, so that's what I want to do. I want to try to fetch this number from the blockchain. So we'll go to Ethers, and we'll say, get block number. That's what we're going to do. We're going to get the latest block number. But before we do that, we have to connect to the blockchain. So this is how you do it with Ethers. You say const provider equals Ethers get default provider Rinkeby. Okay, boom. So this is what's really nice first and foremost about Ethers is if you just want to connect to a test network, which we're doing in this case, you don't have to go fetch an actual Ethereum node URL. They'll just give you a default provider out of the box. So if you've ever used Web3, you'll know that this can be kind of a pain. So for example, I'll show you an example right here. Here's a Web3 version. So if you want to connect to the blockchain with Web3, basically you have to get an RPC URL, which means you have to go to Infura and sign up for one. So basically you would go here, you get an Ethereum node URL, and then you have to go paste it back into your project and then create a new Web3 connection like this. So you don't have to do that with Ethers. You can just get a default provider under the hood. So that's pretty nice. All right, so let's continue on. Let's get the block number like this. We'll say const get block number. We'll create a new function for doing that. So we'll create a function like this, and we'll say async Okay, then we'll say const block number equals await provider get block number. So this is pretty easy. We just call the get block number from the provider here like this. Okay, and then we'll console log it. Console log block number. All right, and then we will say get block number, and so we will log it. We'll call the function that way. So let's make sure this all works properly. All right. So that'll save that. Go back to our terminal here and say node app.js. And boom, there we go. The block number is 68, 34, 48, 84. So it's a little bit, it's a little bit out of sync with this. That's okay. There it is. Perfect. Boom. All right. So that's how we call the block number. So that means everything's set up. That's perfect. We're talking to the Rinkeby test network. Again, that's a test network as opposed to the main Ethereum network here. So this is not real Ethereum that we're dealing with. We're just interacting with the developer environment for the blockchain. So next, let's see how to get the balance. So we do it like this. We basically say provider. Actually, let me kill this and bump the font up a little bit so you can see it. Say provider get balance. It's pretty easy. All right. But let's actually fetch our Ether balance from our account. So what you can do is basically go to MetaMask. All right. And you can copy an account and you can get some fake cryptocurrency and then read the balance this way. So I'm going to go ahead and paste the account in and say const get balance equals await. And then paste this in here. We'll also say await. Let's say let balance equals await provider get balance and paste in our MetaMask address. Okay, make this cleaner. Const account equals this. All right. And then we can say console log balance Ether. Okay. So let's run this. Okay, I had a little problem here. Sorry, I put the await keyword here, so this should be async. All right, let's try it again. And there's the block number, so let's go ahead and comment that out and say get balance. All right. And boom, there we go. So that's working. And then so what we want to do is actually format that balance. So you can see the balance is an object here, or it's a big number, that's what it is. And so let's actually clear this out, just so you can see one example at a time here. And we'll say let balance and then balance equals ethers.utils format ether and say balance. All right, say that. Run this again. And boom, there we go, 12.25 Ether. Now, if you didn't have any Ethereum in your wallet for the Rinkeby test network, you can just go to Faucet. So if you Google Rinkeby Faucet here, you can see this. This is faucet.rinkeby.io, and you can just basically add your Ethereum address here and say give me Ether. So I'll just show you how it works. Click your account, give me Ether, and you can do, there's a wait. So if you request something, you have to wait for a certain amount of time. I'm just going to do 3 Ethers. So what you do is basically, so sorry, I actually have to do a social media post. So basically what you do is you make a tweet, and you say requesting faucet funds into this address, so then you put your address on it, and then you click tweet, all right? And then when you're done, you copy and paste your Twitter link into here, and then say give me Ether, and it will give some to you. And once you have that done, you should be able to successfully run this example. So let's move on. Let's actually interact with a smart contract, okay? So what we're going to do is interact with the DAI token smart contract. So I'll show you what I mean by that. So basically, we're going to go to Etherscan on Rinkeby and look up DAI. So I'll put the address in here. I'll put it in the code so you don't have to look this up. But basically what we're going to do is use Ethers to interact with this smart contract. So DAI is a token, which means it's a cryptocurrency on the Ethereum blockchain powered by smart contracts, and we can interact with it in JavaScript, okay? Basically, we can call its functions. So it's got some pretty important functions on it. We can say like balance of. This shows us how much DAI we have, how much cryptocurrency we have, and then we can see the name. We can write to the contract as well, which basically means we can do things like send tokens. You'll see the transfer function. That's how we do that. All right. So we're gonna do these next couple examples is show you how to fetch your balance from DAI, which will show you how to read information from a smart contract, and then we're going to actually send some DAI cryptocurrency with the transfer function. So that'll show you how to write to the smart contract and actually create a transaction on the blockchain with Ethers.js. So those are 2 pretty critical things to understand if you're trying to develop a dApp. So let's knock those out right now. So again, you need to make sure you have some of that Ether in your wallet on the Rinkeby network. I showed you how to request some with that faucet a minute ago. So if you don't have that, you definitely need that before you continue. So let's show you how to set the DAI smart contract up in your code here. So what you need to do is let's clear this out. And we'll say you need a few pieces of information. So in order to interact with the smart contract, you need the ABI, and then you also need the address. Okay, so here's the address. I just looked that up on Etherscan a minute ago, so you can say const DAI address. Okay, and then we'll do const DAI ABI. Okay, and with these 2 pieces of information, we'll be able to create a JavaScript version of the smart contract that we can use inside of Ethers.js to call its functions, so we can check our balance and also send DAI tokens. Okay, so here's what's pretty cool about the Ethers.js library is you can use these human-readable ABIs. So normally, like with Web3.js, I would have to import that really big ABI file, right? So like I'd have to go to Etherscan, and I would have to copy this entire thing. I go to Code tab, copy this entire thing right here, and pull it to my project, right? And you see this, like here's a Web3 example. So like I get the address, and I have to get this entire ABI, which is like a bazillion lines long, right? So instead, with Ethers, what I can do is just pull in the functions that I want without even having to really look the ABI up. So I'll show you what I mean by that. So what you can do is basically just copy and paste the functions that you want from Solidity and build out a really simple ABI that way. So I'll show you that. If you want to check your balance, all you need is the balance of function, and you can just paste in this literally a string of the Solidity code to the interface like this. So just function balance of address owner view, all right? And then we also want to send tokens, so we can just paste in the Solidity function interface for the transfer function as well. So that's all we need. We just need these 2 functions, and we can just copy and paste part of the Solidity code as a string inside this array to have a human readable ABI. So we can tell exactly what this does, okay? Just by looking at it. So now we can create a DAI version of the contract like this. It looks a lot like the Web3 syntax. So we'll just say, we'll say const DAI equals new Ethers contract. Then we paste in the address, paste in the ABI, and now we need a wallet, okay? So here's what we want to do next. So go to MetaMask, okay? Find your account where you have some Ethereum cryptocurrency on the Rinkeby test network. Copy that address, and let's go above here and say const wallet, and then we'll paste in the wallet address, okay? We'll say let wallet. I'll just show you the syntax here. Boom. New Ethers, capital W for wallet. And then what you need to do is paste in your private key for the wallet and then put in the provider that we showed a minute ago. So I'll show you that. So basically, if you look over here in your .env file, what you want to do is create a new file here, or just update the one that exists, and I'll just show you. .env.example. So we'll say private key, and we'll say 0x, and this will be your actual private key. So I'll try to get this from MetaMask. So go to MetaMask, click this hamburger menu over here, click details, click export private key, put in your password. It'll show you what it is. Okay, so then copy it to your clipboard, but it won't have a 0x in front of it. So you need to make sure you have the 0x, and then you actually put in, you paste in your private key there. Okay, so make sure you do that inside of an actual .env file, not a .env example file. Okay, so I'm gonna delete that. Let's delete it actually. Okay, and so now back inside app.js, we've required the .env file so that we won't store the private key, in the code. We store it as a secret. Okay, so then you'll read your private key like this, add it into the wallet, and then pass it to the provider. Okay, so then next. We'll actually connect the wallet to the provider like this, and then boom, there we go. We're set up to actually have a connected smart contract that's aware of our wallet. It knows what the DAI ABI, knows what the DAI address. Okay, so there's a little bit of step involved to do that, but that's how you create the connection. So now let's get the DAI balance like this. I'm just going to copy and paste this in for an example and explain it. All right. So get DAI balance will look like this. So basically, we just say balance equals await DAI balance of, just like this right here, and we pass in the wallet address, and then we fetch that balance back from the blockchain. Say ethers.utils, format ether, then pass the balance, and then we'll log it to the console. So let's give that a shot, see if it works. And let's say node app.js, and then boom, there you go. I have 10 DAI. So now I got a feeling that you don't have 10 DAI in this wallet, so I'm gonna show you how to get it really quickly. So what you can do is just go to Uniswap, go to app.uniswap.org, and then make sure you're connected to the Rinkeby test network. It's probably stay on version 2, and then you can just buy some DAI for Ether. So what I'm gonna do is swap, 1 ETH, and that'll give me 10 DAI. Click swap, confirm swap, and then click OK, and then boom. It should mine any second now, because the test network transactions are pretty fast. So anyways, I don't need to sit here and wait for this to mine all day, but you get the idea. Well, actually, I might be finished now. Let's see. Yeah, I just got a MetaMask confirmation saying it was done. So that's how you can get some DAI, and then once you rerun this, let's see, yeah, boom, there we go. My balance is updated. So whenever you rerun this, you should see your new DAI balance updated. And if you didn't have any the first time, it'll say 0, but then you can update it and with Uniswap and see your updated balance here. Okay. So the last thing I want to show you to do is how to send DAI, and this will create a transaction. So we're going to use the transfer function, and again, this will write to the blockchain. That's going to transfer tokens, DAI tokens from one account to another, and it'll create a transaction on the blockchain, and you need to sign it in order to do that. So I'm going to get rid of this right here, and then paste in an example like this, and we'll explain it. Okay. So what we're going to do first and foremost is get your balance before the transfer, okay? So we'll just get the DAI balance, that's the function we created a minute ago, and then we'll create an account that we want to send DAI to like this. So you can just go to MetaMask, switch accounts, and then copy this account here, and then paste it in, all right? And then you want to specify the amount, so it's going to be 1 DAI. So Ethers has these nice helpers, say ethers.utils, parse units, say 1, and say 18 because DAI has 18 decimal places. So basically 1 DAI looks like this. 1.0234567891011121314151718, that's what that means by 18, okay? And then after you create the amount, we basically call the transfer function. So DAI transfer, pass in the to address, and then the amount. And so what that does is return the transaction object, and then we can say wait for the transaction to be mined. We'll say the DAI was transferred, and then get balance. Okay. So let's send DAI, and then that's about before. And this will take a second, but we'll see what happens. I'm actually going to leave this in real time to see. Yeah, boom, there we go. Awesome. So it worked, and then the DAI went down by 1. So there you go. That's how you use Ethers.js. Again, this is a really important library if you understand as a blockchain developer because you're going to run into this at some point. I just want to give you a good introduction into this. Web3 is still very popular, but Ethers is a big choice among developers too. So I wanted you all to get to see this. So I hope you like this video. If you got any questions, feel free to reach out. And until next time, thanks for watching Blockchain Mastery University.